All right. Good morning, good evening, good afternoon, good whenever. Jay Sarah. All right, so we're going to go into permutations and then I'll make another video on combinations and that will finish up everything in this section. So let's get started with this. So, definition of permutation. Basically, what a permutation is that we are going to have an ordering of elements. So order matters with permutation. Combinations, order doesn't really matter, but with a permutation, that's the main difference. We need to have order that matters. So let's go over this definition first. A permutation of n different elements is an ordering of the elements right on this ordering of the elements such that one element is first, one is second, one is third, and so on. Oh my God, this thing's not writing very well. And so on. All right, so it says right here, how many permutations of the letter A, B, C, D, and F are possible? So if we were to break this down, we're talking about the first one. Okay, so the first letter is any of the six. Second, any five left, because we pulled one out. It's basically like how we're not replacing one letter again. Third, any four remaining. The fourth, any three remaining. Fifth, any of the two, and of course six is the last one, the final letter. Okay, visually this is what's happening. Okay, 6, 5, 4, 3, 2, 1. That's basically 6 factorial, which is going to equal 720. Okay. All right, a number of permutation elements n. Okay, this is just n times n minus 1, not 4 times 3 times 1. Basically, it's just n factorial. Alright, so you may want to order only a subset of a collection, Such ordering is called a permutation of n elements taken at r time. Okay, so when we're talking about subsets, it doesn't mean that all of them are going to be in there. Okay, so let's take a look at this example first. It says 8 horses are running in a race. In how many different ways can these horses come in first, second, and third? Assume there are no ties. So when it comes in first place, we got 8 different ones to choose from. When it comes in second, okay, we got 7 to choose from. Third, we have 6. Okay, the other 5, whatever, you know, unfortunately, fourth place is a loser in this case. So basically how we're going to do this is just like the previous one. We're going to take 8 times 7, 6, and that is going to equal 336. Another way we can do this, okay, is if we take a look down here where it says day 2, we can use this formula right here. N P R n factorial n minus r factorial, and expand it out, that's this, n minus 1, n minus 2, n minus r plus 1. Okay, as you notice, when we talk about that r plus 1, if you notice that part keeps increasing. So here it's r is 1, r plus 1, that's how we get 2, and so on. That's that part that fills that out. So we're going to use this right up top here. Okay, so our n, okay, is the total number of elements, okay, which is 8. Okay, now our r is talking about r at the time. Okay, r is going to be 3 because we are only taking in 3 spots. In other words, we are saying 8, permutating to 3 of them. Okay, so that's just 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial, which equals 336. Okay, as you get into more difficult problems, you're going to end up using this right here. Okay, all right, so distinguishable permutations. Okay, we don't have much room, but we're going to write this formula right here. Okay, and the formula for that is n factorial and 1 factorial two factorial times n 3 factorial and k factorial. Okay, this n right here at the top is primarily talking about the amount of elements that are in there. Okay, down here, this is talking about how many does each separate one appear in there. You know, we'll look in this example coming up as we speak. So, in how many distinguishable ways can the letters B, A, and N banana be written, basically? Okay, so your book shows all the different ways in there, but here's how we can calculate this. So like I said, the top one right here, It's talking about how many total elements you have in there. So if we look, banana has 1, 2, 3, 4, 5, 6 different letters. So that's where we get 6 factorial here. Okay. Now, if we look at the letters, and we start with the B, okay, B is only there one time, so that's just going to be 1 factorial. Times, if we look at A is there 3 times, so that's going to be 3 factorial. And the next letter is N, and that's there 2 times. Okay, and that's how we fill out that bottom. Okay, so that just ends up becoming 6. Cancel, cancel. It's 3. 6, 5, 4. Missing the 4. Okay. So that is 60. Okay. And that is permutation. I'm going to make another video on combinations just because I need the shorter videos, and shorter videos take a lot less time to upload. All right. Talk to you soon. Bye.